Alright, so let's do another video about hypothesis testing. This time we're going to do this with one mean. So if we check out this problem here, assume that the simple random sample has been selected from a normally distributed population and test the given claim, identify the null and alternative hypothesis, yada 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 yada. So in a manual on how to have a number one song, it is stated that a song must be no longer than 210 seconds. A simple random sample of 40 current hit songs results in a mean length of 235.2 seconds and a standard deviation of 56.32 seconds. Use a 0.05 significance level and Minitab display. We're not going to use Minitab to test this claim that the mean is greater than 210 seconds. Alright, so if we jump right into this, this is about a mean, so therefore our parameter is mu, just like in this problem here, where they want us to test that mean is greater than has no equality in it, so that means that's got to go in the alternative. And so we are looking at either A or D, but remember the null must always have an equality. And so A is ruled out, so we must be using D here. And so check it. Excellent. Alright, so let's jump over. I want to write down the parts. So my null hypothesis, mu, my alternative hypothesis, again, mu. If we jump back real quick, mu is greater than 210 seconds. So erase that. Greater than 210 seconds, and that is also my claim, and therefore this would be less than or equal to, or just simply equal to. Okay, now this is about a mean, so, and there is only one variable, and so I'm looking on the formula sheet. It's going to tell me I'm in one of these first two columns. Now what column am I in? Am I in column 1 or column 2? Now how do you know? Well, is sigma known or sigma unknown? Well, if we jump back to the problem, right, it says a sample. So this one sentence here, a simple random sample of 40 hits results in a mean and standard deviation. That standard deviation is from the sample. That's in that sentence about the sample. So that's a sample standard deviation. Sigma is the population standard deviation. So that's not sigma, that's S. So in other words, sigma is not known, sigma is unknown, so we are in the second column, if you will, and therefore we're going to use the t distribution, and then this is how we're going to churn through this example. Alright, so if we jump back though, maybe make a note of that. Sigma is unknown, therefore we're using a t distribution. Also, we should always check conditions, because again, if your conditions fail, then you can't do the test. Now most of the time the conditions are always going to pass, because if they didn't, then there would be nothing to do in the homework. Now if I'm looking here, what are the conditions? It needs to be either a normal population or the sample is greater than or equal to 30. If we go back to the problem, they did tell us that that very first sentence, assume the simple random sample has been taken from a normally distributed population. So that actually meets our condition. So conditions are met. Alright, so next would be the test statistic. Test statistic is a t, because we're in a t distribution, so x bar minus mu over the square root of, or excuse me, not square root, it'd be S over the square root of n. Again, on the formula sheet, there's that formula right there. So that's what I'm working with. I always like to, again, work on the distribution. If it's a standard normal distribution, well, in this case it's a t distribution though. So 1, 2, 3. It's still going to have this look to it. Again, I like to find the critical value, get my rejection region on there. Again, alpha 0.05, I believe. Let's double check though. It's almost always 0.05, but sometimes it varies. There it is, 0.05 level of significance, so yes. All right. And again, greater than, so that points that way, so that tells you what side the rejection region is on. So now if I want to find that critical value and kind of get a visual of where my rejection region is starting, we can go to StatCrunch. And critical values, again, come from the calculators. But we are using a t-distribution now. And the big thing with the t-distribution is the degrees of freedom. And I did not write that down. So let's go back. What was our sample size? 40. So the degrees of freedom is n minus 1. So let's make a note of that. The degrees of freedom is 40 minus 1, so 39. So if I jump back into here, my degrees of freedom would be 39. I said 49, I meant 39. Alpha is 0.05, and we are going this direction, and therefore my critical value is 1.685. 1.685. And this is a T critical. So this is my rejection region. So if my test statistic lands over there, I am going to reject the null. All right, let's get some things down. What was X bar? We already talked. Let's get N down. These are my statistics, right? N was 40. If we jump back, X bar was 235.2. And S, because again, that was a sample value, and that was 56.32. So if I was to do this manually, this would give me all the values I would need to calculate T, but let's use StatCrunch to actually do the calculation. Again, if you don't know where to go, use the formula sheet. On the very bottom of that sheet tells you where to go to Stat and StatCrunch. And so we are going to go to Stat. We're going to go T-stats, one sample with the summary. Okay, sample mean. All right, I already forgot it. I have a terrible memory. I believe it was 235 point something, 235.2. Sample standard deviation, so S. And so let me jump back. That was 56.32. So 56.32. I do remember N was 40. We are hypothesizing that this is 210. Whoops, wrong window. There we go. 210, and our alternative is pointing that way. So I got everything in there I need. Now if I just hit compute, there it is. And so my test statistic is 2.830, and p-value is 0.0037. So 2.830. My p-value was 0.0037. And so again, when you do your final conclusion, here's my final conclusion box, I guess. We compare P is 0.0037, alpha is 0.00, or not 0.005, just 0.05, sorry. And how do we compare those? 0.0037 is definitely less than alpha. And furthermore, if we throw t up here, where's t? 2.83. That means t is landing out here. So t is in the rejection region. So we're definitely going to reject. But again, we don't say, hey, look at my picture. We use p values. So remember, if the p is low, the null has got to go. In other words, if p is less than alpha, we reject the null. So since p is less than alpha, we will reject the null. And therefore, if I reject the null, I'm supporting the claim because the claim is in the alternative. So there we go. We got all the pieces we need. That would be the problem. So let's just jump back in here, type in our answers, and finish it off. So that was, if I round to 2 decimal places, 2.83. Fantastic. P-value, round to 3 decimal places, let's try that again, 0.0037, so 0.004. All right. So now, which one are we doing? Well, we already said we're going to reject the null, so we are either A or C. And we also said we supported the claim. So A says reject the null. There is sufficient evidence to support the claim that the mean length is greater than 210. What's C say? There is sufficient evidence to support the claim. There is sufficient evidence. Yeah, there we go. I was like, these say the same things, but I couldn't. A says insufficient. Reject the null. There is sufficient evidence to support the claim. There it is. Well done. Thank you. All right, so there it is. We walked through it, showed all the parts in StatCrunch, worked it all out. There's that last part. That last part's a little subjective. So what do results suggest about the advice given in the manual? The results are inconclusive. The results it's just evidence. Let's see here. I always hate this because you gotta go back and recheck everything here. So in a manual, how to have a #1 song is stated that you must be no longer than 210. However, we did support the claim that the mean is greater than 210. So the results suggest that, yeah, that's not sound advice. So if we kind of go through all that stuff. So, ta-da! All right, hope that helped.